So we are now in our final chapter, chapter 3, Karnaugh Map and Conventional Logic Circuits. Okay. So learning outcomes, so how to determine Boolean equations using Karnaugh Map. So there is another way on how to determine the Boolean equation. So aside from Boolean algebra, so we also have Karnaugh Map. Then solve the same problem by analyzing a given problem. Okay, same as with chapter 2, but this time we're going to use Karnaugh Map to generate a Boolean algebra and generate a logic circuit design. Okay, so we've done this in chapter 2. Okay, and then we have the new concept here. So aside from Karnaugh Map, we also have don't care conditions. So how does don't care conditions affects the generation of Boolean equation? Okay, and then we have the universal gates. Why is it NAND and NOR gates are called universal gates? Okay, so let's start. Okay. So introduction. So the Karnaugh map or K-map is an alternate way to determine Boolean equations. So this is a graphical method. Okay. So design problems are introduced in this chapter, and then with a given problem, so you should be able to generate a truth table. Okay, and then truth table, then generate the Boolean equation using K-map. Boolean equation may also be used here. And then once you have the Boolean equation, then you have to make a circuit. You have to make a logic circuit design that is based on Boolean equations. Okay, and then afterwards, don't care conditions will be introduced. Then we will tackle how does this don't care conditions will affect the generation of Boolean equations. So with don't care, actually, the Boolean equation can be simplified, can be further simplified. Okay, therefore you have a simpler logic circuit. And then we will discuss how are we going to implement the given logic circuit using only either NAND or NOR gates. So NAND and NOR gates are um, known as universal gates. Okay, so okay na ba sa inyo itong itong word? Class? Question? Hello? Okay. So, okay, so we're now 12. Okay, where are the others? Okay, so, okay, let's start. Karnaugh map. Karnaugh map is a graphical method of determining the Boolean equation. It is an alternate way of solving for Boolean equation, especially if the number of inputs is 4 and above. Okay. Conventional method of applying Boolean theorems to 4-input problems. So finding the Boolean equation will be tedious. So if you have 4 input problems, so how many possible combinations? So if you have 4 input problems, so let's say you have the inputs are A, B, C, D. How many possible combinations for 4 input problems, class?
16 po.
Okay, so we have 16. Okay, so we have 16 possible combinations. Okay, so example here. Okay, so given the truth table, find the Boolean equation for Z using K-map and draw the logic circuit diagram. Okay, so we have a sample here. Okay. Okay, so we have actually 16 combinations starting from 0 to 15. Okay, so if we're going to use a Boolean algebra, you might as well use what? Min terms or max terms given this truth table, class? Class? if you're going to use the our method in chapter 2 using Boolean algebra, given the um, given truth table, meron. Okay, given the truth table, okay, so what are you going to use? Min terms or max terms?
Max terms po.
Okay, so we'll use max terms, okay? But, okay, so since we only have 1, 2, 3, 4, 5, okay, we only have 5 zeros. So if you have 5 zeros, you might as well use max terms, okay? But then, still with 5 zeros, so that would still be tedious, okay? If we're going to determine the simplified Boolean equation using just the Boolean theorems, okay, or Boolean algebra. But this can be, we can easily find the Boolean equation using the K-map, okay? So we have 4 inputs, so DCBA, 1 output, okay? For each, okay, so for each output, so we will have one Karnaugh map. Okay, one Karnaugh map. Okay, so let's see. So how it's going to be. So since you have 4 inputs, so we'll use 2 by 2. Okay, 2 by 2 K map. Okay. So how is it? Okay, so this is the 2 by 2 K map. Okay, so these are actually the inputs. Okay, so we have the inputs are DC and BA. Okay, so let's say for DC, so you have 2 inputs, so you have 4 possible combinations for D and C, same as with B and A. We have 4 possible combinations for B and A. Okay, the sequence for DC, so it follows the gray code sequence. For 2-bit gray code sequence, so you have 0, 0, 0, 1, 1, 1, and 1, 0. So again, this is a gray code sequence, okay? For BA, also 0, 0, 0, 1, 1, 1, and 1, 0. So for DC, so this is the C, the first bit, and the second bit is the D, okay? Same here, this is C, this is the D, okay? This is the C, this is the D, and likewise, this is the C and the D. Okay. For BA, so this is okay. So this is the A. Okay. So you have the first bit A, second bit as B. Okay. For this one, so you have 1 A, 0 as B. For this one, we have A and B. And lastly, we have this is A, this is B. Okay, so those are the assignment. Okay, input assignment for this column. Okay, this is for 0, 0, 0, 1, 1, 1, 1, 0 column for BA, and per row, so you have 0, 0, 0, 1, 1, 1, and 1, 0. So this is like a matrix. Okay, or we have, this is for number min-term or max-term number 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay? So why? Okay? So min-term or max-term zeros is equivalent to 0, 0, 0, 0. So this is what this square means. Okay? So this squares is an intersection between row 0, 0 and column 0, 0. Okay. So this is input 0, or okay. So this is input 1, 0, 0, 0, 1. Okay. Input 2. What is input 2? Input 2 is 0, 0. So you have 0, 0 here. 0, 0, 1, 0. Okay. And then input 3 is again, okay, 0, 0, 1, 1. Okay. So let's check the truth table. Okay. So it actually pertains here. The number or the min-term number. Min-term, max-term number. So min-term 0, input 0 is 0, 0 for DC and for BA 0, 0. Okay, input 1, you have 0, 0 for DC, BA is 0, 1. Input 2, 0, 0 for DC and 1, 0 for BA. And for input 3, 0, 0, 1, 1. Question class. This can be a bit confusing, class. Please ask your question. Can you follow? Class, can you follow? Class, can you follow? Hello?
Yes po, ma'am.
Okay. Okay. So, okay, let's go back to K-map. Okay. So, we're done with 0, 1, 2, 3 inputs, 0, 1, 2, 3. So, let's proceed with inputs 4, 5, 6, 7. So, for input 4, it's actually input 0, 1, 0, 0 or 0, 100. For 5, we have 0, 1, 0, 1. For 6, you have 0, 1, 10. And for 7, we have 0, 1, 1, 1. Okay? For input 8, so you have 1, 0, 10, 100. Okay? And for input 9, so you have 10, 0, 1. For input 10, you have 10, 10, and 11 is 10, 11. Okay. For input 12, 13, 14, 15. So we have input 11, 100. 13 is 1101. 14 is 11, 10. And 15 is 11, 11. Okay. So again, the inputs are actually based on the truth table. So let's start with input 4. Input 4 is 0, 100. Input 5 is 0, 101. Input 6 is 0, 110. And input 7 is 0, 111. Input 8 is 1000. Input 9 is 1001. Input 10 is 1010. Input 11 is 1011. Input 12 is 1100. Input 13 is 1101. Input 14 is 1110. And input 15 is 1111. Okay? Question. Question? Hello, class? Can you follow? Hello?
Okay po, ma'am.
Okay. Okay. Okay, so this is 2x2 K-map. Okay. So what's next? So inside the square, okay, so we will put the output Z here inside the square. Okay. So again, based on truth table, you already have a value of output Z. So you already have value for output Z. So these values 1 and 0s will be inputted here. Okay. So take note that you already have a corresponding output based on corresponding input. Okay. So let's see. Okay. Okay, so we have, so this is now 1101. Okay, for input 0, so we have, okay. How are we going to? Okay, so we can have comparison side by side. Okay, wait. Okay. Oh, okay. Wait. Why it won't copy? Oh, wait. Uh-huh. Okay. Okay. So let's see. Let's make this. Okay. Um, question, class. I have no question. Okay. 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 So this is the DC. Do you have BA? Let's copy it also. Okay. Copy. And okay. Okay. So again, so we have DC and BA as inputs. Okay. So we have this. So for input 0, 0, so the output is 1. Okay. For input 0, 0, the output is 1. So again, this is this square, okay, correspond to input 0, 0, 0, 0. Okay. Okay. So the DC correspond to the rows. Okay. like this one. This is row 0, 0, row 0, 1, row 1, 0, and row 1, 1. And the BA correspond to the column. So this is column 0, 0, column 0, 1, column 1, 0, and column 1, 1. Okay. So again, for DC, so the first number or the first bit is 0. This is C, and the second bit is D. Whereas for BA column, the first bit is A and the second bit is B. Okay? So we will write the corresponding square. So this square correspond to input 0, 0, 0, 0. This one correspond to input 0, 0, 0, 1. And input 2, 0, 0, 1, 0. Input 3, 0, 0, 1, 1. Input 4, 0, 100. Input 5, 0, 1, 0, 1. Input 6, 0, 1, 10. Input 7, 0, 1, 1, 1. Input 8, 10, 100. Input 9 is 10, 0, 1. Input 10 is 10, 10. Input 11 is 10, 11. Input 12 is 1100. Input 13 is 1101. Input 14 is 1110. And lastly, input 11 is 1111. Okay. Then after that, we will input the Z here inside the square. So for the first square, so this corresponds to 0, 0. So we have an output of 0. Okay. Then for 0, 0, 0, 1, so we have for 0, 0, 0, 1, the output is 1. So we will put 1 here. For input 0, 0, 10, okay. So this is input 0, 0, 10. The output is 1. Okay, so we have 1 here. And for input 0, 0, 11, so we have 0, 0, 11, the output is 0. So we have 0, 0, 11, and the output is 0. Okay, then next we have for input 0, 100. For input 0, 100, the output is 1. So there should be 1 here. For input 0, 1, 0, 1, so we have 0, 1, 0, 1, the output is 1. Okay, the output is 1. And then for input 0, 1, 10. Okay, so 0, 1, 10, the output is 0. So we have 0, 1, 10, so this is 0. And we have for input 0, 1, 11, the output is 0. Okay, so this is 0, 1, 0, 1, 11, the output is 0. Okay, next we have input 1000. Okay, okay. One thousand. Okay. Question, class? Okay, so for input 1000, the output is 1. Okay, so this is it. Okay, so 1000, 1000. For input 1001, so this is 1001, so the output is 0. Okay, base here, the output is 0. Then for input 1010, the output is 1. Okay, so 1010. Okay, so we have 1. Then you have 1011, the output is 0. Okay, this is 1011, the output is 0. And lastly, we have 110, last row and column, last row. So we have 1100, the output is 1. So this is 1100, the output is 1. 1101, okay, 1101, still 1. 1110, okay, 1. And lastly, we have 1111 is 1. Okay, so we now have a K-map. So what's next? Okay, so what's next? What do you think will be next? After that, we will do a looping. Okay, so we have example loop here. Okay, so we only check if the output are accurately placed here inside the map. Okay, K-map. Okay, so we do the looping. So in here, it's either you may use min term or max terms. But in this example, so we have a min terms. Okay, min terms again correspond to outputs of 1 and the looping. Okay, looping still follows the 2 to the n. Okay, 2 to the n such that if n is 0, it's either 0, the loop is 0, 1, 2, 4, 8, 16. So what's inside the loop? It's either 1, 2, 4, 8, 16. So still follows 2 to the n. Okay. So if you want to use min term, so you will include in the loop the adjacent ones, or if it is max terms, adjacent zeros. Okay. So first loop. Okay. So we have 1, 2, 3, 4. Okay, so we have 4 adjacent ones here. So this is the loop. Okay, so color brown or orange. Okay, so we have 4 ones here. Okay, so for the first loop, okay, let's compare D to D, C to C. Okay, so what are the values of C? So it corresponds to 2 values for this loop. It corresponds to 2 values. So for D and C, we have 0, 0, 0, 1. Class, please, if you have any questions, you may ask anytime. You have any questions? Class? Can you follow? Hello? Are you still there? Hello?
None po, ma'am.
Okay, is it clear? Okay, so for loops orange, for the first loop, the loop orange here. Okay, so again, you compare the column per column and row per row and column per column. But you have to compare C to C and D to D. Okay, so if they have this, if they have different, let's say you have 0 and 1 values, so that literal is automatically. So if you see 0, 1, it will be automatically eliminated. Okay, so for this example, so again, so we've chosen the 4 adjacent ones here. So for loops orange, so for D and C input, so let's compare C. So we have 0 and 1. So what will happen to C? Class, what will happen to C? So if you have,
Eliminated.
okay, so C would be eliminated. Okay, so if you have values of 0 and 1, eliminated. Okay, how about D? For D, we have 0, 0. Okay, so therefore D is 0. Okay, D is 0. So since this is min term, when we say D is 0, that is equivalent to, when we say D is 0, D or D prime for min term, class. When we say D is 0 for min term, what is that? D or D prime? Hello? Class? When we say D is 0 for min term, what is that? D or D prime?
D po.
D. Min term. So this is min terms. So when we say D is 0, that is
D prime.
That is D prime. Okay, that is D prime class. Mean term. So take note, what we have included in the loop are the outputs of 1. Okay, outputs of 1, mean term. So when we say D is 0, so you write D prime. Okay, D prime. Okay. Yan. D prime. Okay. So C is eliminated while D is equal to D prime. Okay. How about for BA? Okay, so for BA inputs, so we have 0, 0, and 0, 1. Then you compare A to A. So A to A, so A is first bit, so you have 0, okay, so we have 0 and 1. So what will happen to A? 0 and 1.
Eliminated.
Okay, so eliminated. A is eliminated, whereas B, for B is 0, 0. Therefore, B is 0, both 0. So B is 0, 0, so therefore B is 0. So how are we going to write that? If B is 0 for mean term, so we will write B is equal to B or B prime. Just like in D is 0, D prime. So therefore, for B is 0, so we will write
B prime.
B prime. Okay, so for this loop, so we have, for this loop, okay, so the equation is, the term is D prime, B prime. So we were able to eliminate input C and A. Okay. Okay, so let's take note of that. So we have Z. This is Z, right? Z is equal to D prime, B prime plus, okay. How about the blue here? Okay, so we also have 4 ones here. 1, 2, 3, 4. Okay, so if we're going to compare that with DC, we only have one value, which is D is 1, C is 1. Right? So we cannot compare it with other values. So since the blue loop only encompasses the this value, this row. Okay, so when you say D is 1, C is 1, so how are you going to write that, the equation? When you say D is 1, so what is that? D or D prime? Class, when D is 1, so what shall we write?
D.
Okay, so we will only write D. Okay, D. Whereas when C is 1, okay, if D is 1, D. Therefore, when C is 1, so we will write, hello, class. What are you doing? Can you understand? Are you doing other subjects? I know this is hard. This is actually hard concept, even in face-to-face lecture. So we have to work double time here. Can I have your attention, undivided attention for this? This is a new concept, so this is naturally hard to explain because this is a new concept, but I need your cooperation, your undivided attention. Hello?
Okay po, ma'am.
Po.
How about the others? How many are you now?
14.
13. Oh, 12. Actually, there are 12 participants. How about the others? Can you understand? This lecture is pointless if you don't understand. Hello? Ruben Del Valle. Any question? Hello?
Mahina signal, ma'am. Sorry.
Okay. Esparza.
Ma'am.
Any question, Esparza?
Nalilito lang, ma'am, sa ano kung magiging prime.
Yes, I know. Okay? That's why I need your feedback.
Yes,
Marian. Is it clear, Marian? Paharoha?
Yes, ma'am.
Okay.
Yes,
Justine?
ma'am.
Casado? Any question?
BCB prime, ma'am.
Okay. Jasalva.
Okay
Ito,
naman po,
laging
ma'am.
okay. Doris Bernales.
Ganon din po ma'am sa primer and prime din po nalilito.
Okay. Donald Tagay.
Medyo, ma'am.
Ang alin? Anong medyo?
Medyo po di ko nasimulan, ma'am eh. Kakaten ko lang.
Palmes.
Medyo nalilito din po, ma'am, sa prime po.
Okay. So, Mente, sira ang mic mo, you can chat. Sino yung mga, if you have problems with your mic, you can chat here. Okay, you can ask questions through chat, meeting chat, okay? Relos? Relos. Hello? Jennifer?
Yes, ma'am.
Question, Relos.
Wala po, ma'am.
Okay, may ano ka? May ubo ka rin? Cristobal. Cristobal? Hello, Cristobal? Jade De Maano? Amina Puerto? Iba, sana? Who's this?
Amina po.
Okay. How about Cristobal and, asa na? Cristobal and De Maano. Okay? So, let's review the chapter 2. You've already forgot your chapter 2. Yan na exam nyo bukas. Remember, that's your exam tomorrow. Okay? Okay, so let's review chapter 2. Okay, where is that? Let's review chapter 2. Okay, so can you see now Boolean theorems and logic gates? Can you see
Yes
now?
po, ma'am.
Okay, so let's review Boolean theorems. Okay, so Boolean theorems. So here, okay, so for min terms, so if input is 0, so you write x prime. Okay, input of 1, so you have z and prime. Okay, such that here, if you have 0, 0, so we have x prime, y prime, z prime, 0, 0, 1, x prime, y prime, z, 0, 1, 0 is x prime, y, z prime, 0, 1, 1 is x prime, y, z, 100, x, y prime, z prime, 101, x, y prime, z, 110, x, y, z prime, and 111 is x, y, z. Okay, class? So, all in
Okay
all,
lang.
when you say min terms, when you say 0, so that is prime, okay? Whereas 1 unprime, okay? Such here. So if you z is 1, so you simply write z. Now let's connect that here. Okay. Okay. See this? Okay. K-map. Okay. So again, so we will discuss again the orange loop. Okay. So we'll go back again. Okay. So this is the K-map. So what are these numbers inside this square, class? As a review, what are these numbers? 1, 1 here, 0, 1. What are those numbers again, class?
Outputs, ma'am.
Output, okay? So output that is based on the, we have the, okay, we have the truth table here, okay? So these are the numbers inside the square. Okay, these are the numbers inside the square, whereas the inputs are the numbers outside the square. Okay, okay, so these are the numbers corresponding outside the square. So these are actually inputs. Okay, the numbers inside the square, so such as this one, is actually output z. Okay, so these are again 0, 0, 0, 1, 1, 1, 1, 0. So it actually correspond to input DC. Okay, 0, 0, 0, 1, 1, 1, 1, 0 in input BA. Okay, so for DC, so the first bit C, second bit is D. Okay, for BA, the first bit is A, the second bit is B. Okay, so again for loop 0. Okay, so for K-map, okay, looping is done. So if you're going to loop for 1, so you want to include in the loop the adjacent ones. That means you are after min terms. Okay, so you'd like to simplify using min terms. Okay, min terms again correspond to outputs of 1. Okay, but adjacent ones, okay, so we can only include in the loops adjacent ones. Okay, so it follows 1, 2, 4, 8, 16. Okay, we cannot have 3 ones in a loop, 5 ones in a loop, no 6 ones in a loop, 7 ones in a loop. So it only has to be 1, 2, 4, 8, 16. Okay, so for the first loop, so we have the first loop here, again, orange loop here. So we have 4 adjacent loops. Yung tabi-tabi, adjacent. 1, 2, 3, 4. Okay, so we have 4 adjacent loops. Then you compare the C to C and D to D. Okay. Okay, so with respect to the orange loop, so we have 2 values for D and C. So for DC input, so we have 0, 0 and 0, 1. Okay, then compare C. Okay, for C, 0 and 1. Okay, so if you have different input, okay, so you have both 0 and 1, so that literal is, or that input is automatically cancelled or eliminated. So therefore for C, 0s and 1, so what will happen to C, class?
Eliminate.
Okay, C is eliminated. Okay, whereas for D, okay, D is 0 and 0, so therefore D is 0. Since, okay, so that's why we have here D prime. Okay, okay. How about for input? For input B and A. Okay, for input BA, because we have two values for input BA as far as orange loop is concerned. Okay, so we have 0, 0 and 0, 1. Then compare A. Okay, compare A to A, 0 and 1. So what will happen to A?
Eliminated.
Okay, A is
Eliminated.
eliminated, whereas for B, B is 0 and 0. So therefore, B is 0. So that's why we write B prime. Okay, so for orange loop, the term is equal to D prime, B prime. Because D is 0, B is 0. So again, for min term, if it is 0, so we have A prime. Okay, if it is 1, unprime. Okay, so any question about orange loop?
None po, ma'am.
Okay, none. Okay. Okay, then we have for blue. Okay, let's proceed to blue. Okay, so this is the blue. Okay, so we have 4 adjacent ones again for loop blue. 1, 2, 3, 4. Okay, but for D and C values, we only have one value. So the blue loop actually encompasses only a single row, which is equal to D is 1, C is 1. So we cannot compare D to C. Okay, so therefore for this blue loop, so we can say that D is 1, C is 1. So we will write, if D is 1, we will write, since this is min term, we will write D is 1. D is 1. D. Okay, well, C is 1.
C po.
Okay, so we will write D and C. Okay, because D is 1, C is 1. Okay. How about with respect to BA plane or BA or inputs BA? Okay, so 1, 2, 3, 4. So it encompasses 4 values also for BA. We have 0, 0, 0, 1, 1, 1, and 1, 0. Okay, it encompasses 4 values. Okay, so for this one, we have 0, 0, 1, 0, and 1, 1, and 1, 0. 0, 0, 0, 1, 1, 1, and 1, 0. Okay? Then compare A to A. Okay, let's compare A. 0, 1. What will happen to A?
Eliminate.
Okay, so eliminated. A is eliminated outright because you have 0, 1. Okay? How about B? Let's compare B, the second bit. 0, 0, 1. What will happen to B? Again, 0, 0, 1.
Eliminated, ma'am.
Okay, so B will be eliminated. So for the blue loop, okay, so the term is just equal to DC. Okay. So this is a redundant. Okay, this is redundant. Okay, so we have the one on the corners. Okay, so think of a K map just like a globe, just like a world map. Okay, wherein the east and west are interconnected. Okay, okay, the corners are also connected. Okay, so we can do this on the corners. If you have ones here in the corner, so you can interconnect them also. Okay, so with this, so we have the black loop. Okay, black for the corners. Okay, so we have 4 values. Okay. For DC, we have 2 values, 0, 0, and 1, 0. Okay, and for BA, we have 0, 0, and 1, 0. Okay, so we are talking about ones. looping of ones on the corners. Okay, so we have 4 ones on the corners. Okay, so we group them all together. So you have 4 ones. It seems to be, again, the corners are connected also. Okay, shall we proceed with the third loop? Shall we, class?
Yes po.
Okay, so for the black loop, okay, for the black is this black, okay. So we have values for DC with respect to DC. We have 0, 0, and 1, 0. Okay. Again, for DC, we have 0, 0, and 1, 0. Then we compare C. C to C, 0 and 0. So what will happen to C? What is C? C. Okay, C prime. Okay. How about for D? Okay, D is 0 and
Eliminated.
1.
Eliminate.
Okay, D is eliminated. Okay, let's proceed to BA. Okay, so we have two values, 0, 0, and 1, 0. Okay, so we have ones here. Okay, so let's compare A, 0, and
A prime,
0.
A prime.
Okay, A prime, whereas B is 0 and 1.
Eliminate.
Okay, so therefore for this for the truth table, given truth table using K-map, so the Boolean equation is just simply equal to Z is equal to D prime B prime plus DC plus C prime A prime. Okay, as long as you don't get confused with looping, so this is actually easier. Any question with this? Let's check. Okay, let's check. D prime B prime plus DC plus C prime A prime. Okay, okay, so we have the same answer. Okay. See? So Z is equal to D prime B prime plus DC plus C prime A prime. Okay? Okay. So given the equation, so how we're going to draw a circuit. So D prime B prime, so we have D prime B prime here. So we have 4 inputs DC BA. D prime B prime, then add it, okay, plus then we have DC and C prime A prime, okay, C prime A prime, C prime A prime, C prime, okay, and then or these together, D prime plus B prime plus DC, and another OR gate to put them all together such that we have Z is equal to D prime B prime plus DC plus C prime A prime. Question?
Ma'am.
Yes.
Ma'am, yung D prime tsaka B prime, pwede po ba yung gate doon, NAND gate?
Yes, we can NAND. No.
Opo, ma'am. Hindi na
You
po
may use
lalagyan ng
you
inverter.
may use the Morgans here. So if you're going to take out the prime outside such that it becomes DB, then prime outside, then but you have to change the
Wala nang inverter, ma'am.
This is the inverter. See? Tama ba? D prime, B prime. Hello? Did I answer your question? This is D prime, B prime. We have an inverter here.
Yes, ma'am. Thank you, ma'am.
Okay. But actually, there is an alternate for that. Okay. Okay. So for Z, so you want it using the Morgan's principle. Okay. D, B. Okay. You took out the prime here. Okay. But then you have to change the operator from times to
Plus.
plus. Okay. And this one is equivalent to, what is this? You OR first, then you not. What is this? D plus B is? What gate is this, class? D
NOR
plus
gate, ma'am.
again? D plus B is
Or
OR,
gate po.
then
Gate.
NOR gate.
inverter. So this is actually a NOR gate. Okay. So this is actually a NOR gate. Okay.
Iba pala yung operation.
Okay. So you can further simplify the equation. So using the Morgan's principle again, so D prime B prime can be equivalent to NOR gate. Okay. So you have plus DC plus, okay, so you have another case here. So you see A, so you took out the prime outside, but you have to change the operation from
Addition.
primes to plus. Okay, so you have another, so it means that you have another, okay, so you have another NOR here. Okay, so this is actually simpler. So instead of using for D prime, B prime, instead of using inverters and, so you may use a single NOR. Okay, so that means with this equation, so all you need is two NOR and of course OR, isn't it? So what are the gates that we need? Okay, so you need and for plus you need OR. Okay. Clarifications. Question? Question, class? Question? Okay. So, question? So with this, okay, so let's have this one. Okay. Okay, so it also explains here, okay. Okay, that is your activity actually. That will be your seat work, okay. Redraw the logic diagram replacing the two inverters and one AND gate with NOR gate, okay. So that will be your assignment, okay. To be submitted on Wednesday. So you have activity 3.1 here.
Ito diagram lang, ma'am.
Yes. Okay, redraw the logic diagram replacing the two inverters. Okay, so what I have explained, so ito yon. So applying De Morgan's principle, so we can replace D prime B prime with D plus B open close parenthesis prime and C prime A prime is equal to C plus A open close parenthesis prime with which is in fact a NOR gate. Okay, then you redraw the logic diagram replacing the two inverters and AND gate with NOR gate. Okay, question. Okay, so how about this one? Okay, we have another example. A question with example number 1, class.
Wala po.
Okay, is it clear? Not yet. Not yet. Okay, so let's have another example here. Okay, so the given is a canonical equation. So we have function of DCBA. So you have inputs DCBA and the output is F. Tama ba? Summation of 4, 5, 14, 15. What does summation means? Mean term, max terms?
Mean
Class. Okay, mean terms. Okay, mean terms 4, 5, 14, 15. So that means these numbers have output of 1. Okay, mean terms. Okay. Then we have here, okay, so what are the mean terms numbers? So we have for mean terms number 4 and 5, we have 1, and 14, 15, we have 1. Okay, so first loop. Okay, so let's have the, okay, so F is equal to, okay, so for the first loop, okay, what color is this? Black. Okay, black loop. Okay, so we only have one value for DC, which is 0, 1. So therefore, D is 0, C is 1. So how are we going to write that? This is mean term
D
also.
prime C, ma'am.
Okay, so we'll write D prime C plus, okay, for this one, for the violet loop. Okay, so we only, okay, I'm not yet done with black loop, sorry. Okay, okay, so For black loop, we have D is 0, C is 1. But however, with respect to BA input, so we have two values which are 0, 0 and 0, 1. Then again, compare A, 0 and 1. What will happen to A?
Eliminate.
Okay, A is eliminated, whereas B 0, 0. Therefore, B is 0.
prime.
So we will write B prime. Okay, so for black loop, again, for black loop, the equation is D prime C B prime. Okay, plus, okay, plus, okay. Okay, let's have the violet loop here. For violet loop, we have the value for violet loop. So we have for DC, we only have one value. So we have D is 1, C is 1. Okay. So therefore, what are we going to write? If D is 1, so we will write
D.
okay, D and C is 1.
C.
Okay, DC. Whereas for BA input, so we have two values. We have 1, 1 and 1, 0. Okay, so we have 1, 1 and 1, 0. Then you compare A to A. For A, we have 1, 0. What will happen to A?
Eliminated, ma'am.
Okay, eliminated. Whereas for B, we have B is 1, 1. Therefore, B is 1.
B, ma'am.
Okay. Again, DCB. Okay, so we have DCB. Okay, so therefore the equation for this is F is equal to D prime CB prime plus DCB. Okay, so we have the same answer. So we have D prime CB, and DCB. Okay, so from this we can factor out C. Okay, we can factor out C such that F is equal to C times D prime B prime plus DB. Okay, but again, D prime B prime plus DB is actually equivalent to an XNOR. Okay, XNOR. So we can simplify that using D XNOR B. Okay, so we say D XNOR B is automatically equal to D prime B prime plus DB. So such that with that we can this equation comes down to this. Okay, so all you have to do is to put the input DB to XNOR and then another AND. Okay. Okay, so that will be your F. Question. Question. This one's better. Okay. Question, class? None?
None po. Ma'am.
Okay. D XNOR B. Okay. So this is D XNOR B times C. Okay. Okay. Next we have. Okay. We have another example here. Okay. We have third example. FDCBA is equal to pi 8, 9, 12, 13. So pi. So pi is min term or max term?
Max term.
Okay, max term. So that means these numbers 8, 9, 12, 13 has an output of
0.
0. The rest
Zero.
are ones. Okay. So we have this such that this one. Okay. So we have 8, 9, 12, 13. So you have an output of zeros. Okay. Okay. Okay, the rest are ones. Okay, so if that is so, using max terms, okay, we can group this adjacent force here, okay, to just a single loop. Okay, so we only have a single loop. So with this, F is simply equal to, okay, using max terms. So for DC, we have two values encompassing this loop. So we have 1, 1, and 1, 0. Then you compare C. Okay, for C, 1,
Eliminate.
0. Okay, C is eliminated, whereas for D is 1, 1. D is equal to
D prime.
D is 1, okay, max terms, okay. So again, this is max term. So when you say max term, when D is 0, that is D. When D is 1, that is D prime. Class?
Yes, ma'am.
Question, class? So we are now max terms. Okay, let's have a review. Let's review the max terms. Okay. Okay, max terms. Okay, max terms. Okay, so this is the max terms. So if you have input 0, 0, 0, okay, the output is x plus y plus z. For input 0, 0, 1, x plus y plus z prime. For input x, y, z, 0, 1, 0, 0, 1, 0, the output is x plus y prime plus z. For input 0, 1, 1, the output is x plus y prime plus z prime. For input 100, we have x prime plus y plus z. For input 101, so you have x prime plus y plus z prime. For input 110, the input x prime plus y prime plus z. And 111 is x prime plus y prime plus z prime. Okay? So you have plus in between literals. Okay. Okay, going back here again, C is eliminated since the values for C is CR 1 and 0, so C is eliminated. Whereas for D is 1, 1, so D is, again, this is max terms, D
Prime.
Okay. Plus, okay. For BA, we have two values for the black loop. So we have 0, 0, and 0, 1. Then you compare A, 0, 1. What will happen to A?
Eliminated.
Okay, A is eliminated. Whereas for B, B, 0, 0.
B.
Okay, D prime plus B. Okay, so this is just the black loop. Okay, the black loop is just simply equal to D prime plus B. So the Boolean equation for FDCBA is equal to pi 8, 9, 12, 13, just simply equal to D prime plus B. So to implement this, all you need is just an, for prime, we have, what gate shall we use for prime?
NOR gate.
Inverter. Okay, so we'll just simply use inverter, and for plus, we will use
OR gate.
for plus.
OR gate.
OR gate. So all we need is just an inverter and an OR gate. Okay? Okay, we're done. Okay, we're done for today. Okay, so your assignment is activity 3.1. Okay, do you need any more example? More examples? Do you need more examples, class?
Ma'am, ba't po dito, dun po sa last, minultiply?
Saan?
Dun po sa unang example.
3.1.
Po.
This is min term. Min terms.
Okay.
Okay.
But,
Min terms is sum of products. So, yung terms between literals, multiplication yun. Then, between terms, add. Whereas for max terms is
Product of
yan,
uh,
product of sums. So you have to add first, then you multiply. It's just that in this example, we only have one term per loop. Okay, so let's try another examples here. Okay, so I'll try to answer number 6. Okay. Okay, so I'll try to copy this one. Any question, class? Please answer. Please feel free to ask. It's really hard to teach this lecture, this one. Even in face-to-face lecture, it's really hard. Oh, this is pi. You want more max terms? Okay. 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 I'll just, okay. It says here 8, 9, 10. Okay, so I'll answer number 3. Oh, wait. Okay, number 6. I'll answer number 6. Max terms. So let's try max terms. Okay. It says here, this is 1. Okay. Okay, 2. Okay. Max terms 2 are the max terms numbers 2, 6, 10, 11, 14, 15 have an output of what will be the output of these input numbers, class? 2, 6, 10, 11, 14, 15. So number 6 says function of DCBA. So you have inputs DCBA is equal to pi 2, 6, 10, 11, 14, 15. What does this mean?
0 po. Output
Okay,
0.
so the input numbers 2, 6, 10, 11, 14, 15 has an output of 0. So let's try to find those. So we have 2, then you have 6, then we have 10. Okay, 10, 11, then 14, 15. Okay, the rest are ones. Okay, the rest are ones. Okay. Okay. Sorry, 11 is also zeros. Okay, so how many is 1, 2, 3, 4, 5, 6? So we have 6 zeros. So 1, 2, 3, 4, 5, 6. Okay, so we can have this one and okay, and another loop. Okay, so we can have another loop. Okay. Okay. So let's have the black loop first. Okay, so this is F. F is equal to, so let's have for the black loop, class, black loop, we have 2 values for DC. So we have 1, 1 and 1, 1, 0. Okay, so then compare C to C. So C, 1 and 0. So what will happen to C?
Eliminated.
Okay, C is eliminated, whereas for D, 1, 1. D is equal to 1, therefore we will write
D prime.
okay, D prime. Okay, so this is max term, class, max term. So for max term, 0 is unprimed, whereas 1 is prime. Okay, so again, we're not yet finished with the black loop. Okay, so let's compare the BA input. So we have 2 values for the black loop. We have 1, 1 and 1, 0. Okay. Then compare A. Okay. So we have 1 and 0. 1 and 0. So what will happen to A? 1 and 0. A is eliminated, whereas for B is 1, 1.
B prime.
Okay. Plus B prime. Okay. So that will be our first term. Okay. This will be our first term. Then second term, we have blue here, blue loop here. Okay. We have blue loops. Okay. Blue loop. Okay. For blue loops, we have how many values for D and C? So we have 4 values. So it encompasses 4 values for DC plane or DC inputs. Okay. So we have 0, 0, 0, 1, 1, 1, and 1, 0. Okay. Okay. Then compare C. Okay. C 0, 1. What will happen to C? 0, 1.
Eliminated.
Okay. C is eliminated, whereas for D, 0, 0, 1.
Eliminated.
Okay, D is also eliminated since it has a mixed values of 0 and 1. How about for BA? Okay, so for BA, with respect to BA, it only has 1 value. Okay, the blue loop only has 1 value, which is equal to B is 1, A is 0. Okay, we cannot compare B and A, so we will write B is 1, B is 1, B is B prime plus A 0
A.
A. Okay. Okay. So now the equation for this, okay, for number 6 is equal to pi 2, 6, 10, 11, 14, 15 is just simply equal to D prime plus B prime times B prime plus A. Okay, for your assignment to be submitted on Wednesday, please do number 3 and activity 3.1. Then exam tomorrow. Our exam is tomorrow, chapter 2. Please review chapter 2. Okay, so Boolean algebra. Will you do Boolean algebra, min terms, max terms, and circuits, drawing of circuits, logic circuits based on Boolean, given Boolean algebra or simplified Boolean algebra. Any question, class?
Anong oras test bukas, ma'am?
9 po, 9. 9 o'clock.
Salamat po.
Oo. Oh, mag-load na kayo, ha? So, I'm going to download this attendance list. Okay. Pakisabihan nyo din, classmates, we have an exam tomorrow, 9 o'clock. Okay?
Ma'am, natatanggap po ito sa YouTube?
I will upload this in YouTube also.
Salamat po.
Okay. Any question? Okay. None?
Wala na po.
Clarifications natin. Okay. So anyway, if you have any clarification, so just review this video. I will upload this in YouTube. Okay. So that's all for now. So I hope you study for tomorrow. Okay. So actually, this subject is a foundation for your future subjects also, for your advanced subjects such as PLC. So dapat talaga matutunan nyo talaga itong subject na ito, class. This is just a basic subjects for your course. Okay, so you have a even bigger application for this subject, which is PLC. So that is already an industrial applications of your subjects. Okay. Microcontrollers, meron din to. Okay, yung logic dito. So I hope you could grasp this subject, the concept of this subject. Okay? Any questions? Okay? So that's all for now. Okay? So take care. Pataas ng pataas ang COVID natin na. Yung nasa everywhere. Ayan. Yung mga, kaya ingat-ingat kayo ha. Bawal kayo lumabas. Below 21, bawal lumabas. Ilang taon na ba kayo?
Ay, pwede ako.
Pwede ka na? Huwag ka pa rin lalabas. Kung hindi kinakailangan, no? Ayan. Yung kaso ko nga, ano lang, asthmatic cough. Ayaw pa rin mawala nung ubo sa akin. Mahal na mahal nga ako. Musta? Okay na? Mag-aral kayong mabuti, ha? Okay, so this subject, even if you pass this subject, kung wala kayong natutunan, sayang lang ang panahon nyo. Because this has, again, this is just a basic subject. This has a bigger application in your advanced subjects such as microcontroller and PLC. Okay, PLC, and the PLC has an industrial application na yun. Industry-based na siya. So, dapat pag-aralan nyo talaga mabuti itong subject na to. Okay? Question?
Ma'am, hindi ba may credit ko ng computer fundamentals dati?
Computer fundamentals.
Oo, dati. Ito rin yung subject namin, ma'am, ng computer fundamentals.
Nag-aaral din kayo?
Calculator.
Boolean Equations and Karnaugh Map?
Hindi ko lang matandaan nun kasi uminto ako nun.
Hindi mo na pala matandaan eh. Di ano. Hindi ko alam kung anong scope ng ang computer fundamentals eh. O dapat pala ma-perfect mo na exam ko dahil meron ka na palang background dito, 'di ba? Tawa?
Hindi naman po, ma'am.
Anyway, ang mga subjects naman talaga, it is purposely na, anong tawag doon, nag-overlap so that may connection sila sa isa't isa. Okay, so may overlap, this subject may have an overlap with, topics with computer fundamentals, pero may mga bagong namang topic to na wala din sa computer fundamentals. I don't know if computer fundamentals has logic circuits then. Actually, chapter 3, chapter 2, that is already designing, introduction, and chapter 3, ini-introduce na rin kayo sa designing, logic circuits design. Okay?
Okay, ma'am.
What we are discussing is actually introduction to logic circuits design. Unti-unti lang. Hindi pwedeng biglaan. Okay? Because just like in our topic today, the K-map, it would be a bit confusing if I'm going to drop everything in one session. Okay, question, chapter 2, again, chapter 2, please study. Okay, so as you can see, our lecture in chapter 2 overlaps with chapter 3. So we have introduced the logic circuit design, okay, ganun pa rin, and we all have a Boolean equations. It's just that I have introduced a new way how to determine the Boolean equation using K-mapping, but still the same thing, okay? Any more questions or clarifications?
Wala naman.
Okay, thank you. Okay, thank you, class. Thank you for attending my class, and I hope you learned something from today's session. Okay, so please study now. Study. Okay, so keep on studying. So make sure that you get something from all your subjects, otherwise sayang lang panahon na ginugol nyo dyan kung wala kayong natutunan. Okay, so keep safe for now and bye.